Today we'll be learning about blood and lymph, two very important bodily fluids.
Blood composes about 8% of our body weight. The average adult has about 5 liters of blood. Hematocrit is the percentage of blood cells in a blood sample. A blood sample is usually 45% red blood cells and 55% plasma. Plasma is a mixture of water, proteins, carbohydrates, lipids, vitamins, electrolytes, and cellular wastes. Blood cells originate in red bone marrow from hemocytoblasts or hematopoietic stem cells. Thrombopoietin stimulates the production of megakaryocytes, which are the origin of platelets. Red blood cells are also called erythrocytes and are biconcave in shape. They contain hemoglobin, which is responsible for oxygen transport. The biconcave shape of red blood cells allow them to have an increased surface area for increased binding of oxygen.
Red blood cells are biconcave.
The average adult male has between 4,600,000 to 6,200,000 cells per millimeter cubed. The average adult female has between 4,200,000 to 5,400,000 cells per millimeter cubed. Any deviation from this could be a sign of disease. Anemia and cancer are the most common reasons for a low red blood cell count.
Low hematocrit is bad.
Erythropoiesis is the process of creating new red blood cells. In a fetus, RBC production occurs in the yolk sac, liver, and spleen. However, once the baby is born, RBC production occurs exclusively in the red bone marrow. RBC production starts with the hemocytoblasts. These cells develop into erythroblasts, which develop into reticulocytes, which then mature into erythrocytes. The hormone that controls the production of RBC is called erythropoietin, and it's released from the kidneys. Low oxygen in body tissues causes erythropoietin release.
Body tissues with low oxygen causes the production of red blood cells.
Red blood cells usually last around 120 days before they are too damaged to function properly. The liver and the spleen act as the body's filter system. Macrophages, a member of the innate immune system, destroy the damaged cells. The hemoglobin molecules are broken into globin and heme groups. The heme further degrades into iron and biliverdin. The biliverdin is converted to bilirubin in the body's tissues. An excess of biliverdin or bilirubin in the blood is characteristic of a hemolytic disorder like hemolytic anemia, where your immune system attacks your red blood cells.
I'm a macrophage. I am a damaged red blood cell.
Macrophages destroy damaged red blood cells in the liver and spleen.
White blood cells serve to protect you from diseases. There are 3 types of white blood cells: granulocytes, monocytes, and leukocytes. Granulocytes have granules in their cytoplasm, which are full of digestive enzyme. The 3 types of granulocytes are neutrophils, eosinophils, and basophils. Monocytes are composed of dendritic cells and macrophages. These are all part of the innate immune system. The adaptive immune system consists mostly of T cells and B cells. 25 to 33% of circulating white blood cells are leukocytes. White blood cells protect your body from invaders. Diapetesis is the movement of white blood cells from the bloodstream into the surrounding tissues. The white blood cells move using a form of self-propulsion called amoeboid motion.
Platelets.
Platelets, or thrombocytes, are essentially megakaryocyte fragments. They stick to the sides of broken blood vessels and help clog the hole. They also release serotonin, which causes the walls of blood vessels to constrict, limiting blood flow.
Too much serotonin causes spasms.
Blood isn't all solid though. That would be bad. 55% of it is a watery fluid called plasma. It serves in transporting nutrients, gases, and vitamins. It helps regulate fluid and electrolyte balance and helps maintain a favorable pH.
Hello class, here we have some pooled normal plasma.
The 3 main plasma proteins are albumins, globulins, and fibrinogens. Albumins help maintain the osmotic pressure of blood and make up about 50% of plasma proteins. Globulins transfer lipid and fat-soluble vitamins in the blood. Fibrinogen helps blood clotting. The two most important gases in blood are carbon dioxide and oxygen. The body needs to take oxygen to the tissues for respiration and needs to take carbon dioxide away for removal. Plasma also contains amino acids, simple sugars, nucleotides, lipids, potassium, calcium, magnesium, chloride, bicarbonate, phosphate, and sulfate. Wow, what a mouthful.
This is plasma. This is some calcium chloride. And this is some tissue factor, which is released in response to trauma. Okay. This is the fibrin clot, which stops bleeding in blood vessels.
The first step is the blood vessel spasm. This is when the walls of the vessel constrict to decrease the blood flow. Serotonin from platelets causes this reaction. Next, platelets adhere to the exposed ends of the blood vessel. Platelets and collagen clog up the hole to stop any additional bleeding. After the platelets plug the hole, clotting factors in the blood turn fibrinogen to fibrin. This fibrin surrounds the platelet clog, holding it in place. The resulting plug is called a thrombus. Over time, the clot retracts and the vessel heals. When clotting goes awry, though, bad things can happen. A clot that breaks off the vessel wall is called an embolus. If this floating mass gets caught in another vessel, it can clog it and cause an embolism. The cells behind the vessel begin to die as their nutrients are cut off.
You can't fail a blood test, but the worst you can get is an O-.
It's true. There are 8 types of blood: A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative. Your type depends on the antigens you have on your red blood cells. If you only have the A antigen, you have type A minus. If you have the B and RH antigens, you have B plus. If you have neither A nor B, then you have O. Radical! The smallest tube in the lymphatic system is the lymphatic capillary. These are microscopic, closed-ended tubes that extend into interstitial spaces. Fluid flows from these spaces into capillaries. When many capillaries connect, they form lymphatic veins. These are similar to veins in that they have valves that prevent backflow. The larger vessels lead to lymphatic nodes, which empty into lymphatic trunks. These lymphatic trunks lead to one of the 2 lymphatic ducts, the thoracic duct and the right lymphatic duct. After leaving the collecting duct, the fluid re-enters the venous system. Lymph fluids come from a buildup of interstitial fluid. As the circulatory system cycles through the body, some fluid is left over in the tissues due to differing osmotic pressures. The lymph system drains all this extra fluid out and prevents buildups. The lymphatic system also serves some specialty purposes. In the small intestine, it helps absorb dietary fats. Across the body, the lymphatic system can return proteins and foreign bodies to the blood system.
Shout out to the lymph for helping me absorb these dietary fats.
The hydrostatic pressure is what supplies the initial pressure to move the lymph. The rest comes from muscle movement. Even with the constant squeezing from muscles, lymphatic vessel contains very little pressure. They rely on the valves to prevent backflow. Lymph nodes in general serve to filter potentially harmful particles from lymph and to monitor body fluids. Along with the red bone marrow, lymph nodes are centers for lymphocyte production. Lymph nodes are located across the lymphatic system. They contain lymphocytes and macrophages. They have afferent vessels that carry fluid into the node, and efferent vessels that carry the fluid out. Peyer's patches are special lymph nodes in the small intestine that monitors intestinal bacterial growth.
Oh hey, didn't see you there. We just learned about blood and lymph. Thank you for watching.
Whoopie scoop, scoop dee whoop, whoop dee scoop dee poop, poop dee scoop dee whoop, whoopie dee scoop whoop poop, poop dee whoop scoop, poop.